Example 2 says Mr. Kwan is selling tickets to his concert where he exclusively sings covers of Cardi B songs. Mr. Kwan finds that if he sells tickets for $50 each, he can sell 1,200 tickets, but for each $5 he raises the price, 50 less people attend. What price should he sell the tickets at to maximize the revenue? So the revenue function in this case is going to equal number of tickets sold. Sorry, the price of tickets sold times the number of tickets sold. So let's make a little table. So here is the price of tickets. And this is the number of tickets. And then this will represent the revenue gained. So if we sell the tickets for $50, then we can sell 1,200 of them, and we would multiply 50 times 1,200, which ends up being $60,000. And if we raise the price by $5, so $50 plus, and I'm going to write it kind of in a weird way, but 5 times 1, so that's essentially $55. Then we're going to have 1,200 minus 50 times 1. And so our revenue is going to be 55 times 1,200 minus 50 is 1,150. And if we multiply that, our revenue in that scenario would be $63,250. And then if we increased the price by another $5, which would be $60, then we would only have 1,100 people in attendance. And I'm going to write it like this again. So we'd have 60 times 1,100, and that's equal to $66,000. So in general, if I start off with $50 and then add on some number of $5 or some multiple of $5, then I'm going to have 1,200 tickets and subtract off the same multiple of 50 from the number of tickets. So in that scenario, if I multiplied those, then our revenue function would be 50 plus 5x, and that would represent the price of the tickets. And then the number of tickets sold would be 1,200 minus 50x. And so there, at the forefront of things, what we want to work with is our revenue function. So we have 50 plus 5x times 1,200 minus 50x. And I'm going to go ahead and multiply and expand that out. And if we expand that, we get 60,000 plus 3,500x minus 250x squared. And now I want to take the derivative of our revenue function. And if I do that, we get 3,500 minus 500x. Okay, so now what we want to do is we want to find our critical values. So I'm going to set that equal to 0. And we're going to solve that. So if I add 500x to both sides, we get 500x is equal to 3,500. And then if I divide both sides by 500, we get x is equal to 7. Okay, so we got x equals 7. Now I'm going to use the second derivative test. So I need to take the second derivative, and that is equal to negative 500, which means that our function is always going to be concave down. And so x equals 7 gives us a relative maximum. Now, the original question was asking what price should he sell the tickets at to maximize the revenue? And you want to be really careful because it kind of seems like the final answer is $7, but that is not what x equals 7 represents. Recall here that the price of the tickets was equal to 50 plus 5x. And so if we plug in x equals 7 into 50 plus 5x, we get 50 plus 5 times 7. And again, that represents the price of the tickets. So 50 plus 35 is equal to $85. And so your final answer would say to maximize profits, Mr. Kwan should sell tickets for $85 each. And it didn't ask for this, but if you evaluate R of 7, that results in a profit, or not profit, a revenue of, sorry, this word should say revenue, to maximize revenue. So R of 7 ended up equaling $72,250. So if you sell tickets at $85 a piece, then this is the amount of revenue that Mr. Kwan would make. If the total cost function C equals C of X, then the per unit average cost function is C bar, which equals C of X divided by X. Note that the average cost per unit is undefined if no units are produced. Example 3 says if the total cost function for a commodity is given by C equals 1/4 x squared plus 4x plus $100, where x represents the number of units produced, producing how many units will result in a minimum average cost per unit. Find the minimum average cost. So we need to find our average cost function, which is just equal to our cost function divided by x. So we want to divide every term by x, and that will give us 1/4 x plus 4 plus 100 over x. And instead of 100 over x, I'm going to rewrite that as 100x to the negative 1 power. And if you are thinking that I did that because we're going to take the derivative, then you would be absolutely correct. So we have c bar prime of x. We're taking the derivative of the average cost function, and that is going to be 1/4 plus, or actually minus, since we're bringing down the exponent, so minus 100x to the negative 2 power, and I'm going to go ahead and rewrite that as 1/4 minus 100 over x squared, and I want to combine that into one fraction, so I'm going to find a common denominator. So I'm going to multiply this by x squared over x squared, and I'll multiply this by 4 over 4, and we'll get x squared minus 400 over 4x squared. So I'll just rewrite that. Our derivative of the average cost function is x squared minus 400 over 4x squared. And now we want to set that equal to 0 and solve for x. And whenever we set a rational function equal to 0, we are essentially just setting the numerator equal to 0. So let's go ahead and do that. Let's set our numerator equal to 0 and solve that. So we end up getting x is equal to 20 and x is equal to negative 20, but x is representing the number of units that we're producing. So having a negative value for x in the context of this problem does not make sense. Now, We want to use the second derivative test like we've been doing, so I'm going to find the second derivative of the average cost function. So we want to do bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So if we do some simplification, we would get 8x cubed minus 8x cubed plus 3200x over 16x to the fourth. These first two terms will cancel out, and 3200 divided by 16 is 200, and the x in the numerator will cancel with one of the x's in the denominator, so our final second derivative function will be 200 over x cubed. And if we evaluated this at x equals 20, that would be 200 over 20 cubed, which is some positive number. So our graph would be concave up, and we have a relative minimum, which is what we wanted. And so thus the minimum average cost per unit occurs if 20 units are produced and the minimum average cost is C bar of 20, which if you throw that into your calculator, you should get $14. So that is our final answer for example 3.